Okay, Bella, let me give you a few pointers here on how to add and subtract polynomials. So far, we've been doing multiplying and dividing all week, and I think you'll find that today is a nice break from that because what we do is a lot simpler today. The adding and subtracting piece is much easier than the multiplying and dividing. That said, it's crucial for what we do tomorrow when we finish the week, so we need to make sure that we understand it. We're going to look at simplifying expressions by combining like terms. That's something we've done before. Except today, obviously, it's going to contain polynomials. And then we're also going to focus on how to write polynomials in standard form. And that's actually very, very simple to do. That sounds difficult. Trust me, it isn't. Okay, so to keep in mind this here. This is really the most important rule, the only rule that you'll need to know when it comes to adding and subtracting polynomials, is that the terms that you're adding and subtracting, the terms that we're combining, must have identical variables as well as identical exponents. So I give you an example of this here, right? So if I have this term here, 4x squared y cubed z, I have this monomial, and I'm adding it to this monomial, 2x squared y cubed z. Now you'll notice that these variables and their exponents are all identical. So I can add this together. I add the coefficients 4 and 2, and that gives me 6x squared y cubed z. It's really the same thing as saying 4x plus 2x equals 6x. The variable stays the same, right? The x doesn't change. We just add the 4 and the 2 to give us 6. It's the exact same concept here. Just know that we can only add those coefficients if the terms containing variables and exponents are identical. Here's a good example of one that cannot be simplified. It looks like it could, but if you take a closer view, even though it has all the same variables, x, y, and z, the exponents are different. Now, if I were multiplying this, yes, we could. We could multiply, add our exponents. You know how to do that. But because the operation is addition, these are not like terms, and I cannot add them. Okay, so keep that in mind as we look at just a couple of examples here. I want to do 2 addition examples with you and then 2 subtraction examples. Now for this first one here, I'm going to do this one here, the 5f plus g minus 2. We have this polynomial in parentheses being added to this polynomial in parentheses. And the nice thing is that whenever the operation is addition, we can really pretend as though the parentheses aren't even there. So this is really just the same thing as saying 5f plus g minus 2 minus 2f, because I'm just saying plus negative 2f, plus 3. And then we combine all our like terms, and standard form really just means that you have the highest exponent first. And that really doesn't apply here. So for this one, it's just going to be, well, 5f combines with negative 2f to give us positive 3f. I have a positive g. There are no other g's, so I just include that. 3f plus g, and then I have a negative 2 and a positive 3, and that combines to give us positive 1. So that's our final answer there in standard form. This polynomial, 3f plus g plus 1, is the simplified version of this. Okay, now for this, we're going to do this fourth problem here together. I have 2h squared minus 5h plus 7h minus 3h squared. But again, because this operation is addition, I can really just disregard these parentheses and add all the like terms. Keep in mind, not only, even though they're all the same variable, the exponents are different. So 2h squared is going to combine with negative 3h squared to give me negative h squared, because 2 minus 3 is negative 1. And then I have a negative 5h plus 7h. This 7h is positive. So negative 5h plus 7h gives me positive 2h. And I took special care to write this with the h squared term coming first, because standard form, which I'll elaborate on more today, simply dictates that the highest exponent has to come first. If we had an h to the third power, that would be over here written first. But this one is just simply negative h squared plus 2h. Nothing more we can do with that. This is simplified. Now, we are going to see some subtraction examples today, and the only thing you have to keep in mind here is that when you subtract a polynomial, you must distribute a negative 1. So, for example, this first one here, 11m minus 7n, this one doesn't change. It's just 11m minus 7n. And then I'm subtracting 2m, right? So I distribute this negative to the 2m, so that becomes negative 2m. But I'm also subtracting the 6n. So I'm not going to write plus 6n, I'm going to write minus 6n. So you can see that both were positive to begin with, and I'm writing them as negatives. I'm simply distributing a negative 1 to the second polynomial. This cleans up pretty easily. 11m minus 2m is going to give us 9m. Negative 7n minus 6n is negative 13n. And we're done with that one. And then for to wrap things up here for our video, I'll do this fourth example with us. Negative x squared plus 3x minus 5x plus 2x squared. Okay, so I'm going to leave this first one the same. Negative x squared plus 3x. Distribute the negative, so I get negative 5x minus 2x squared. And now we combine our like terms and we write it in standard form. So my negative x squared is going to combine with my negative 2x squared to give me negative 3x squared. And then I have my 3x minus 5x to give us negative 2x. So our final answer is just negative 3x squared minus 2x. Okay, bunch more practice coming with this today. We'll look at some examples like this as well as some trickier ones, and that's pretty much it.